We are starting with section 3 of chapter 2, that is product and quotient rules. And also we have got another subject later, another notion, that's higher order derivatives. You're already familiar, we have already studied the differentiation rules from the first and second section of the chapter 2. You know how to differentiate functions that are given to us. If there is summation, addition, subtraction, if it is a constant multiple, you're already familiar with those. But how about if two functions are multiplied together? How can we deal with them? How can we take their differentiation? We have got product rule. If we have got two functions, okay, f of x multiplied, look here, we have got multiplied to g of x, both together, and we want to take the derivative of this one. How do we take that derivative? That would equal to the derivative of f multiplied to g itself. Look, I'm taking the derivative of f multiplied to g without any change, plus derivative of g multiplied to f of x. So next time, first I'm taking the derivative of that one and multiplying it to g without any change, and then I'm taking the derivative of g multiplying it to f without any change of the f. So in general, we can say that this is the first function and the second function. I always write it like that. That is number one function and that's number two. I will always say first one is derivative multiplied to the second one, plus second one is derivative times first one. Okay, so let's give an example about that. We are given example 2, 3, 1. A function is given to us for the curve y that's equal to 2x plus 1 multiplied to 2x squared minus x minus 1. The required are, it says find y prime. Okay, so the first requirement, it's required from you to find y prime. Let's see how can we find the derivative of that function. Of course, three requirements are given in that example, but we will do it step by step, one by one. The function here is given to us as y equal to 2x plus 1 multiplied to that one, so there is a product rule. First function, okay, that's the function f, okay, or we can say that's the first function, and that one is function g, or as I said, we can say it is the second function. How do we take the derivative of this one? We know from the rule y prime is equal to first one's derivative. I'm taking the derivative of this one. It's equal to what? The derivative of 2x plus 1, that's equal to 2. Okay, of course I'm not writing the 1 because it's equal to 0. Always when you're taking the derivative, put each part in a bracket, in a parenthesis, okay, so that later you will not make any mistakes, because there sometimes you have got more than one term. If you're not putting it inside parenthesis, you cannot make it to the end, because you would get wrong answers. Okay, so derivative of f multiplied to g, I will write g as it is, okay, without any change, because it's given like that to me in the rule. Then I have got addition from the rule, okay, plus the derivative of the second one, or the derivative of g, is equal to what? The derivative of g, that's equal to 4x minus derivative of x is equal to 1, and the derivative of this one is 0, multiplied with the first function. What's the first function that I have got? It is 2x plus 1. So that is the derivative of the product of this function with that function. Now I'm doing simplification, because you have to do simplification as the upcoming requirements makes you to simplify those notions. So I'm multiplying this one to inside simply, okay, this one to this and that, and of course this multiplies to both of them, and that one multiplies to both of them. Let's see what will we get. 2 multiplied to 2x, that's 4x squared. 2 multiplied to that minus 2x minus 2. Then plus 4 multiplied to 2, that is 8x squared. 4x multiplied to 1, that is 4x minus 1 multiplied to 2x, it's minus 2x, minus 1 multiplied to that, it is minus 1. We are looking for the like terms. What are the like terms that I have got? I'm adding x squared with x squared. I have got minus 2x here, 4x here, and minus 2x here. Okay, so we are adding the like terms. And then I have got minus 2 and minus 1, the numbers together. So 4x squared plus 8x squared is equal to 12x squared. Then I have got minus 2x is equal to minus 4x plus 4x is equal to 0. So there would be no x inside that terms. And then minus 1 and minus 2 is equal to minus 3. So the derivative of that function is equal to 12x squared minus 3. The second requirement, it says find an equation for the tangent line. So what is required from us? Equation of a tangent line to the curve at the point where x is equal to 1. Look, this one is given, that one is the requirement, finding the equation of a tangent line. How do we find equation of a line? If you remember from the first chapter, what do we have? How do you find equation of a line? We have got two ways of writing equation of a line. Slope intercept form, that was equal to y equal to mx plus b. Here no b, no y intercept is given to me, so I will not use this one. And we had slope point slope form of an equation of a line. That was y minus y naught is equal to mx minus x naught. When I have got a point and slope, then I can use that equation of line to find the equation that's required from me. So the first thing that I will do is y minus y naught is equal to mx minus x naught. Okay. What do I need here? I need slope and a point. Okay. To find that equation of line, I need slope and a point. A point is given to me. That x here that's given to me is the x naught. How do I find y naught? Of course, if you remember, of course, that's very easy. That's a fact. If x is given to me and I put it directly into the function that I have got, I will get y. So to get y naught, I have to put x1 into the function. So that would be 2 multiplied to 1 plus 1, okay, multiplied to 2 multiplied to 1 squared. Look, I'm putting that one into those x's here so that I get y, that's y naught in here, minus 1 minus 1. What is that equal to when you finding this when you're evaluating this one, you will get 0. So the point that I have got is equal to what? Is equal to 1, that's given to me, that one, okay, and 0. Where did that 0 come from? It came from here, we found it. Now I have got the point. I also need slope to find the equation of the line. How do I find slope? If you remember from the first section, we said we can find slope when we find the derivative of the function. So to find the slope m, what do I have to do? I have to put x1 into the derivative, okay? That's equal to y prime at point 1, okay? I'm finding that derivative at that point so that I can get the slope for that equation. So that one is equal to 12 multiplied to 1 squared minus 3. 12 minus 3 is equal to 9. So the slope is equal to 9. Now I'm coming to the equation, okay? Y minus y naught is equal to 0. It's equal to 9 slope x, that's, I will write it as it is, minus x naught, that is equal to 1. So that equation is equal to 9x minus 9. Okay, so that is the equation of a line where x is equal to 1. That's a very important and nice question that you have got in the course material. I always love this question. Okay, the third requirement. It says find all points on the curve where the tangent line is horizontal. What does that mean if a line is horizontal? If you have got something like that, x and y axis, if a line is horizontal, okay, tangent line is a horizontal. For example, if the curve is like that, okay, that's the tangent line of it. What does it mean if tangent line is horizontal? That means the slope is equal to 0. Okay. If you remember, we studied this one while we were talking about slope. I think it was in chapter 1. Slope is equal to 0 when the line is horizontal, and it is undefined if the line is vertical. So it says find those points where slope is equal to 0. Tangent line is horizontal, gives me the same thing as, let me write it for you here. When I say where the tangent line is horizontal, what does that mean? That means find those points where m is equal to 0. This gives the same meaning. You're doing that procedure. Okay, where m that we have got is equal to what? M is equal to 12x squared minus 3. Okay, and of course that's the y prime. And here you can say that it's the same thing as saying y prime is equal to 0, because m is equal to the derivative of the function, so it gives the same meaning. Now I have to equalize this one to 0 because I'm searching for those numbers that makes the first derivative equal to 0. Okay, slope is equal to 0, that means y prime is equal to 0, and I'm finding those x's where it makes it equal to 0. So I'm taking that 3 to the other side. Okay, that would be 3, dividing both sides by 12 to get rid of that. So x squared is equal to 1 over 4, taking square root for both of the sides, so x is equal to plus or minus 1 over 2. So when x is equal to 1 over 2 and negative 1 over 2, the derivative of the function will equal to 0. What does that mean? That means the slope is equal to 0. And what does that mean? That means the tangent line is horizontal. So at those 2 points, the tangent line would be horizontal for the given curve there. That's all about product rule. We have got quotient rule. Okay. If you're done with the product rule, quotient rule is pretty much the same thing as the product rule, only something very simple different from it. So we have got f of x over g of x. Okay, and we want to take the derivative of this one. How can we find the derivative of this one? That would be, again, the derivative of f multiplied to g, like we had in product rule, derivative of f multiplied to g, but instead of the positive we have got negative sign, and again the derivative of g, okay, multiplied to f without any change. Look, it is the same thing, only this one different. And then I have got something else also, that is all over denominator squared. Okay, so that's an easy rule, you're already familiar with it. We have got an example. We have got 2.3.4. A curve is given to you. It says differentiate. Y is given to you as x squared minus 5x plus 7 all over 2x. So what shall we do? That's the function f above. That's f, and that one is g. How do we take the derivative of that? Using the rule, y prime is equal to, first we have got a long line, okay, division bar. First one's derivative, what is the derivative of f of x? That's equal to 2x minus 5, okay? The derivative of f is equal to 2x minus 5. Multiplied to g, we are writing it as it is. Then I have got a negative sign. Then the derivative of g is equal to 2. And then multiplied to f. What is f? It's equal to x squared minus 5x plus 7, okay? Then all over the denominator squared, 2x all squared. Let's try to simplify this one a little bit, okay? So this 2x is multiplied to that 2x and this 5, and 2 is multiplied to this and that, of course with the negative. Okay, so 2x multiplied to 2, let me draw a straight line. 2x multiplied to 2x, that's equal to 4x squared. 2x multiplied to minus 5, that's minus 10x. Minus 2 multiplied to x squared is minus 2x squared. Minus 2 multiplied to minus 5, that is positive 10x. Minus 2 multiplied to 7, that's equal to minus 14, and all over 2x squared. Again, we are adding the like terms. What are the like terms that we have got? We have got 4x squared with 2x squared. We have got 10x with 10x, and the 14 is alone, a number alone. Okay, so 4x squared minus 2x squared is equal to 2x squared minus 10x vanishes with plus 10x. Again, then minus 14 all over, okay, sorry, that one is 4x squared, okay, because 2 to the power of 2 is 4x squared. That's 4x squared, and that is the result. You're just applying the rule. So if you already know the rule, that would be very easy for you to do the differentiation for the function that would be given to you. Okay, that's all about quotient rule and product rule. Okay, now we are moving to second or higher order derivatives. So what is second and higher order derivatives? You already know the first derivative of a function. We are simply taking the derivatives either using something simple, or we will have product rule or quotient rule. How about if it is required from you to find the second derivative of the function, or the third derivative, the fourth derivative? These ones are called, of course, the second derivative is second derivative, and when it's required from you to find the third and the fourth derivative of the function, it's called higher order derivatives. You simply, when it's required from you to find the second derivative of the function, you simply find the derivative of the first derivative, nothing more. So let me give an example. Okay, if f of x is given to you as, for example, x to the power of 6 minus x to the power of 5 plus 4x to the power of 2 minus 10. Okay, if it is required from you to find the first derivative, that's equal to what? That's equal to 6x to the power of 5, okay, minus 5x to the power of 4 plus 2 times 4 is equal to 8x, and that one is equal to 0. How about if the second derivative is required from you? How do we find it? Look, second derivative, it has got 2 primes on it. We simply find the derivative of the first derivative. Okay, so that would be 5 multiplied to 6, that will be 30x to the power of 4 minus 20x to the power of 3 plus 8. That is called the second derivative of the function. So we are simply taking the derivative of the first derivative, and we will get the second derivative of the function. How about if the fourth derivative, or let's say the fifth derivative, is required from you? Okay, it's written like that, fifth derivative. It's required from you to find the fifth derivative. To find the fifth derivative, we must have the fourth derivative. To have the fourth derivative, we must have the derivative of the third derivative, I mean, and so on. So we've already found the second derivative. Now we are finding the third one. Third one, 4 multiplied to 30 is 120, x to the power of 3, minus, that would be 60x, and that one is equal to 0. The fourth derivative is equal to 3 multiplied to 120 is equal to 0, 6, and 360, x squared minus 60. That's the fourth derivative. What's the fifth derivative of the function? We are taking the derivative of the fourth one, so that would be 720x, and that's the fifth derivative of the function. Okay, so whatever derivative is required from you, whatever order is required from you, you're simply taking the derivative of the previous one, and each one requires the derivative of its previous one, and so you can find the derivative of that thing that's required from you. Here we have got something. We have got f to the power of 5 in brackets, and we have got f to the power of 5 of x. What's the difference between this one and that one? If I'm given f, for example, it's equal to say x squared, okay, and it's required from you to find the fifth derivative of this function and f to the power of 5. Here, f to the power of 5 without parentheses, that means I'm multiplying that function to itself 5 times. So x squared multiplied to x squared, x squared, x squared, and x squared. 1, 2, 3, 4, 5. If it doesn't have any parentheses, that means the function that we've got is multiplied to itself 5 times. So that one is equal to what? X to the power of 2, 4, 6, 8, and 10. Okay, but if it is required to find that kind of f with the 5 in the parentheses, that means you are finding the derivative, the fifth derivative of that function. So the first derivative of the function is equal to 2x, the second derivative is equal to 2, the third one is equal to 0, the fourth one is equal to 0, and the fifth one is equal to 0. So differentiate, I mean make a difference, not differentiate, make a difference between that parenthesis and that 5 without parenthesis. So this parenthesis, that means differentiated, okay, 5 times, and that 5, that means multiply the function to itself, multiply itself, okay, 5 times. Make a difference between those. You've got a simple example, other simple examples from the course material. I will not do those examples because they are already easy ones. That's all about the section 3 of chapter 2. Hope you would understand every concept that I have explained for you, and bye for now.